Welcome to day 14 of the Advent of Code 2022 in Rust. So today we've gone into a cave and there's sand falling from the roof, but luckily the structure of the cave will hold some of the sand. So we're going to try and work out how long it's going to take for the sand to start falling out of this structure and becoming a problem for us. So we're given a diagram of a cave, which is given as a list of lines to draw. So each pair of coordinates tells us where to draw between. And then we get something like this as the result, with sand dropping from this X position 500, Y position 0, and it will fall down if it can. If it's blocked by other sand or a rock, it will then try and move diagonally down and left. If that doesn't work, it'll try and move diagonally down and right. So this will fill up to look something like this. So our problem is going to be to parse the input and then figure out where the sand will fall to, and try and work out how much sand fell into the cave before it started overflowing and becoming a problem for us. So let's get into it. We'll start with the parsing for part 1. So we read the input file and run through every line in it. We separate that by this arrow specifier, which tells us that there's a break between a pair of coordinates. Then we keep track of the previous coordinate and the current coordinate. We parse those into a tuple of usizes. And then if the X is constant, then we'll fill in a column. And we have to be careful here because it doesn't always give them to us in order. So sometimes it's drawing upwards, sometimes it's drawing downwards. So we'll use the min and max to resolve that. Then we fill in those points as rock, and the same if the Y is constant, we fill in a row. So the result of that comes out looking like this. So I've temporarily renamed the air so that this is all lined up nicely for this print. And then you can see where all the rocks are. So we'll be dropping in sand, it'll fill up down to the left, and if we follow the shape down, you can see we get various different shapes to fill in with sand all the way down to the bottom, and at some point near the bottom it will fall off the edge. So it's when it gets to here and starts falling off into the void that we're done. So that's our problem to solve. So let's get back to the code. So I've gone about the solution to this in a fairly simple way. So I've got an outer loop that's controlling all of our sand. We start from our starting position every time. We loop down through all the possible positions for that piece of sand that we're dropping. If we can move it down, we move it down. If we can move it down and left, we do. If we can move it down and right, we do. As soon as we can't move it, it must have stopped. So we fill in that position on the grid with sand. We track the amount of sand we've got total. We break for this piece of sand. We go around the loop again and start with a new piece of sand from the top and drop again. And then finally, when the sand position, its Y position, is out of range, then we stop, because that's falling out of our shapes then. So fairly straightforward loop, and that keeps track of how much sand we want, which should be the answer to part 1. So let's check that out. Let's run it with a sample input first, just to check we're on the right track. And that's saying 24, which is the right answer for the sample problem. And then we can try it with my input, and that's saying 1298 pieces of sand. So let's see if that's right. So let's see if it is. Excellent, we're on the right track. On to part 2 then. So part 2, rather than giving us a void after the shapes we've been working with, it's asking us to draw in a floor after the bottom. So it's saying 2 below the bottom of the cave that we currently thought we were at. So where the void used to start, we go down 1, 2 rows and fill that in with rock. And then we're being asked to fill in still from the same point on the grid, except that now we continue on until the piece of sand we drop in stops right at the top. So basically building up this triangle. So how much sand do we drop in like that? So the first thing we'll need to modify is our cave building. So given that we're dropping at the point 500, 0, and we're trying to build a triangle here, let's assume that the tip of our triangle will be exactly centered, and we'll have enough width on the left given to us by the problem. So let's just make this 1000 so we have enough space on the x-axis. And then we'll also want to add to the end of the cave. So we already have code that pushes in air. So once we've truncated the cave to cut it off at the bottom, which is what we were doing for the part 1, let's push in a row of air and also a row of rock to be the floor. So that's that. Then we need to modify how we drop sand in and what our end condition is. Okay, so let's start by copying what we've already done. To get ourselves a new cave, We don't need the Y-band anymore because we can't fall off the bottom. It's got a rock floor. So we can drop the condition we used to finish last time, which was when we ran out of the edge. And then our end condition now is that the piece of sand we've just dropped finishes in the starting position. So we should be able to just check in here if the sand position is equal to 500, 0, which is the starting position. If it is, then we are done. So let's see if that gives us the right answer. So we'll start with the sample input. So that should give us back a 93. And it does, good. So let's try it with a full input. That's saying 25,585. So let's see if that's right. Let's give that a check. Excellent. So it's right. But ran pretty slowly. It took nearly a quarter of a second, that one, which is pretty slow. So instead of doing it that way, where you start from the top like the problem tells you and drops the sand every time, you could instead keep track of where you've been and backtrack and then go forwards when you reach a point where you can. That would be a lot faster. So that would be a way to modify the problem. And the other thing you possibly do, because we know we're building a triangle, we know exactly how many pieces of sand there are going to be in that, all we'd actually have to work out is how much empty space will be left. What are the unreachable points? Which we already have a pretty good idea of after part 1. So you could use part 1 to solve part 2, but that is still a good win, and I will see you on Friday for day 15 and 16.